factors are very much like vectors, and the only difference really is that a vector can take on any kind of values, while in a factor you can only store data that has a limited number of values, or levels as they are called in factors. And examples on where you can use factors or should use factors is, for example, if you're storing gender, which couldn't be any value, or school grade, which just has a number of levels. And whether you choose a vector or a factor to store your data in, that has an impact on some of the statistical tests that you can perform in R, and it also influences the way that R treats the data when you try to plot it. It gives different sorts of plots. And to make a factor, you use the command factor, and then you just give R the data that is to be stored in the factor, and you provide that in the shape of a vector. So combine here makes a vector containing the values 3, 1, 1, 5, and then you put that into the factor command and you get a factor. And if you ask R to present the factor, you get the values 3, 1, 1, 5, just like a vector, but then you also get this attribute levels with 1, 3, 5. And as you can see, you have 3 levels and 4 values in this factor. And the levels are just chosen by R automatically. It goes through the data and finds out that there's a 3 and the 1, another 1 and the 5. And the ones are obviously identical, so they are the same level. And they are also presented in alphabetical order. And if you really want to make sure that this is a vector, you can use this sort of useless command isVector x, and it gives you false, proving that this is not a vector. And isFactor gives you true, telling you that this is a factor. And to prove that vectors are not quite the same as factors, I'll give you an example here in R, where we create a vector with 4 elements, 3, 1, 1, 5. And if we look at this vector, it looks like this, an ordinary vector, and we can, as you've seen previously, calculate the arithmetic mean of these numbers, 2.5. And you can plot them, and what you get if you plot them is, well, you simply get the dots here at position 1, 2, 3, and 4. If instead we make a factor f containing the vector v, basing the factor on the numbers stored in v, and we look at the factor f, we get the same numbers, but we also get the levels, as I showed previously. If we try to calculate the mean of these values, we don't get a mean. Although they look like numbers, they are no longer numbers, but they are simply labels. They are levels of the factor. And it's not meaningful to calculate something on these labels. And therefore, R refuses stubbornly to provide an arithmetic mean. And if you try to plot them, you won't get the same plot either, but you get a bar plot, as you can see here. So what R does is that it calculates the number of occurrences of each level and then presents them as a bar plot. And in this case, this might have been some sort of grading scale ranging from 1 to 5. And as you can see, we don't have any 2s and 4s in this factor, and therefore R only found the levels 1, 3, and 5. But in reality, there might be a level 2 and a level 4 as well. And we can force R into understanding this by providing the attribute levels when creating the factor. So we recreate f and lets it contain v, the data v, and we give it the levels 1 to 5. Close this picture here. If we look at f now, we get the same numbers, but as you can see here, we have levels 1, 2, 3, 4, and 5. And if we plot this factor, we get the bar plot once again, but we also have bars for the levels 2 and 4 with 0 height, because there are no occurrences on these two levels.